Welcome to class 7 mathematics classes. Today we are going to start a new chapter, data handling, chapter number 24. In this chapter we will be understanding about some important terms like data, statistics, observations, raw or ungrouped data, variable, variate, array, range, hypothesis test, mean of ungrouped data, frequency distribution, tabulation of data, frequency, mean of tabulated data. So these important terms we have to understand. Okay, like data, a collection of information in the form of numerical figures is called data. So example, sports and number of students. Okay, so among the students 40 students are playing cricket. Okay, this is the information collection of data. 30 students are playing football, 25 students are playing tennis, 20 students are playing badminton, and 25 students are playing volleyball. So this kind of collection of information is called as data. Okay, so next is statistics. So statistics, it is the science or branch of mathematics, you can say, which deals with the collection, presentation, analysis and interpretation of numerical data. So in this branch of science or in this branch of mathematics, we deal with numerical data. We collect from the sources, okay, and we present in the mass. We'll analyze what is going on, okay, we'll try to understand, and then we'll say something about this numerical data that we have collected. Okay, the whole process is called as statistics and it is one of the branch of mathematics. Okay, so in this branch of mathematics our chapter is named data handling, which we are doing right now. Next is raw or ungrouped data, when some information is collected. Okay, from where you are collecting? From the source or from the mass, okay, and presented randomly, then it is called a raw data or ungrouped data. Raw data and ungrouped data has the same meaning. Okay, so example, the marks obtained by 10 students in a test, okay, are 40, 32, like this, okay, up to 27. So this is the example of raw data collected from a class, okay, of student, that the marks obtained by them. Okay, so this is the raw data and it is presented randomly. Okay, 40, 32, 15, 36, 9. So there is no any rules over here, no sequence. Okay, it is not in ascending, not in descending. So this kind of collection of data and presentation is called as raw data. Okay, which this data will process, will analyze and will interpret. So that is what the topic statistics. Okay, next is a variable. So variable is a quantity which is being measured in a survey. Okay, survey means like in class we have collected the information about heights of different students. So that is a survey. It's called a variable. A quantity which is being measured in a survey is called a variable. So the variable in this case is the height. Okay, it varies person to person, the values varies person to person, that is why it is called as variable. So that is a quantity for which a data is obtained, is called a variable. Okay, so example, heights of different persons, monthly incomes of different persons, the collection of data. Here we are collecting the data of different person about heights, we are collecting the different monthly incomes of different persons, okay, and we are collecting the population, number of people in a locality, okay, and we are collecting population of different localities. So these all are the variables. It varies person to person, it also varies person to person, it varies localities to localities, okay. So population varies localities to localities. In some locality, few number of people are living. In another locality, okay, more people are living. So that kind of information collection is called as variable, okay. Height, monthly income, like this. So now next is variant, a particular observation that gives the value of variable. So there we observe the height of a boy and we recorded one observation, so that is a variate, okay. Example here, height of a particular boy is 150 centimeters. So this is the variable, height is the variable and this is the variate, okay, 150 centimeter. Monthly income of a particular man is rupees 1500. So monthly income is the variable and this is the variate. Population of some place is 1 lakh, okay. So the population of that particular place is the variable, this population is the variable and variate is 1 lakh. So like this we have to understand. Next is array, an arrangement of the numerical figures of a data, the collection of data, okay, when we arrange them, okay, an arrangement of the numerical figures of a data in ascending or descending order is called an array, okay. So as an example, here is the example. The marks obtained by 10 students in a test are 40, 32, 15, 36, 9, 23, 48, 25, 13 and 27. So this is the raw data that we have collected, okay, from a class. So 10 students are there and the marks obtained by them are here, but it is not arranged in ascending or descending, okay. So we have to arrange these all data in ascending to process the information, okay, or descending also we can arrange. So here we'll arrange in ascending order, okay. Ascending order, this one will be 9, 13, 15, 23. The values are increasing here, okay, ascending. 25, 27, 32, 36, 40 and 48. So here we have arranged this. So this kind of arrangement is called as array, okay. So do remember. Next is range, okay. The difference between the highest and the lowest values of observations in a data is called the range of the data. So here in this data, the lowest is 9 and the highest is 48. So the difference of these two is the range of this data. Difference of these two means 9 and 48, okay. 9 and 48, these two, when we find the difference, then we'll get the range of the given data, okay, the range. So now the difference between the highest and the lowest values of observations in this case is range of this data, of above data, will be equal to highest minus lowest data, okay. Highest is here 48 and lowest is here 9. That is 48 minus 9, that is how much? 39, okay. So here is the range. Here is hypothesis test. A hypothesis test is a statistical test. Okay, statistical test means collection of data. Okay, studying about those data, arranging it, and finding the result. So statistical test is that is used to determine whether the information obtained from a sample of data applies to the entire data or not. Okay, so whatever we are collecting from the mass, okay, or from some source is applied to the entire mass or entire quantity. Okay, then we are doing some hypothesis test. Okay, hypothesis test can be used to evaluate many different parameters of a data such as mean, mode, median. These are very important terms that we'll discuss after this. Okay, and it is very important to understand, because while doing exercises we'll try to find mean, mode, median, range. Okay, these all things we'll try to find in our exercises. So a hypothesis testing is a formal procedure for investigating our ideas about the world using statistics. It is most often used by scientists to test specific predictions, like in astronomy. So this kind of testing is called as hypothesis prediction. Okay, specific prediction is called as hypothesis that arises from theories. Okay, so in hypothesis test we'll try to find the relation between variables. Okay, and there are few steps while testing. First is collection of data, then processing that statistical test will do, then presenting the findings of results. Okay, so hypothesis test is like this. Now here we'll try to understand mean, mode, and median. Okay, do remember the range. Highest value minus lowest value is the range of the given observations. Now mean of on group data. So mean is like an average. Okay, we used to find average, so like that only it is. Arithmetic mean or simply mean, okay, is the sum of given observation. Okay, the observation, the total observation, okay, total of that observation, numerical data observations, that sum is divided by number of observation. So mean can be calculated by this formula, sum of given observations by number of observations. Okay, thus if n observations, x1, okay, x2 dot means x3, x4 is there, x5 and so on up to xn are given, then their mean is calculated as mean is equals to x1 plus, that is the sum of given observations, x1 plus x2 plus x3 plus x4 and so on. We'll add and we'll find the sum of the given observation divided by the number of observation. Total number of observation is n. If n observation means total number of observation is n. Okay, so n, x, these all are variables we are taking help to understand. Now this can be written as by this symbol. This symbol is called as sigma. Okay, but we can call it as summation xi, okay, by n. Summation xi means the total of this observation. So as an example, observation of heights of students. Okay, 150 centimeter, 145 centimeter, 155 centimeter, 148 centimeter and 149 centimeter. So these are our observations. Now sum of given observation to find the mean, so we have to add these all observations. So when we add So mean will be equal to sum of the observation. So here the observations are like this. The sum of these will be 150 plus 145 plus 155, 148, 149. We'll add this and divided by the number of observation. How many observations we have done? 1, 2, 3, 4, 5. So divided by 5 to calculate the mean. It is just like the average only. So here the sum is equal to 747 and number of observation is 5. When we divide, we'll get as 149.4 centimeter. So this is the mean. Okay. So here we have understood that mean is equals to sum of given observation by number of observation. Okay. Now the frequency. The number of times a particular observation occurs is called its frequency. The number of times, how many times it is occurring, the same observation, okay, will determine the frequency of that observation. Okay. Example, in a survey of 20 families, okay, we are observing 20 families of a town. The number of children, okay, of each family in a family were found to be as under. In a survey we are observing 20 families and we are trying to find out each family how many number of children are there. Okay, so we found in one family 2, another family 3, another family 3, like this. 1 1 3 1 1 2 2 2 3 0 1 2 2 1 2 2 1, like this number of children each family are having. Okay, so we have observed, this is the raw data we have collected. Now we'll arrange this, okay, to know the frequency. So after arranging, we got like this in ascending order. 0 is 1 time, 1 is how many times? 7 times. 1 2 3 4 5 6 and 7. Okay, so here 7 ones are there. That means 7 families are there having 1 children, and there is 1 family having no children. Okay, there are 8 families having 2 children, and there are 4 families having 3 children each. Okay, so we have arranged in this way. Now the frequency of having children 0, that is no children, is 1. The frequency having 1 children is 7. Okay, and the frequency of families that are having 2 children is 8. Okay, and similarly the frequency of having 3 children among these 20 families is 4. Okay, so 4 families are having 3 children each, 8 families are having 2 children each, and 7 families are having 1 children each, and 1 family is there without a child. Okay, so this is the frequency of number of children. Okay, now next is tabulation of data. Arranging the data in a systematic form in the form of table. Okay, in the form of table, when we arrange the given observation, okay, then it is called as tabulation of data. So in the form of a table, we'll present the given observations. Okay, then that will be called as tabulation of data. Okay, now frequency distribution. Okay, so from this example only, let us try to make a frequency distribution table. Okay, where number of children is one variable. Okay, and we'll see the frequency of number of children in each family. Okay, that will be called as frequency. Okay, and tally mark we have seen in our lower classes also. Here also let us try to understand. Okay, so here number of children are, the lowest is 0 and the highest is 3. So we'll write here 0 1 2 3. Okay, and tally mark for this 0, how many are there? 1. So here 1. Having children 1. How many families are there? 1, 2, 3, 4, 5, 6, 7. So here 7. In tally mark, we'll do like this: 1, 2, 3, 4, and 5 got. Okay, 6 and 7. So here we'll write 1, frequency 1, here 7, and 2. How many are there? 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we'll do the tally mark: 1, 2, 3, 4, 5, 6, 7, 8. Here 8. Okay, and number of children, how many families are there? 3. Okay, when number of children is 3, how many families are there in our observation? 1, 2, 3, 4. So we'll do the tally mark: 1, 2, 3, 4. Okay, so here frequency will write as 4. So this is the frequency distribution, and this is very important. We'll do few questions in our exercises about frequency distribution. Okay, mean of tabulated data, the tabulated form of observation, okay, that we just saw. Now to find the mean of that kind of tabulated data, we will try to understand here. Let the frequencies of n observations, okay, many observations are there, n observations we'll call. Okay, so observations frequency, like observations x1, x2, x3, and so on up to xn. Okay, that means n observation we have done. The frequency of our observations, let it be f1, f2, f3, f4, and so on up to fn respectively. Okay, then the mean will be given by this formula. Okay, that is the sum of the product of frequency and the observation, that is f1 into x1 plus f2 into x2 plus f3 into x3 plus so on up to fn into xn. Okay, divided by the sum of the frequency. Okay, so it is represented by this formula: summation fi xi divided by summation fi. Okay, that means this is the sum of the product of these two. Okay, that is the frequency and the observation divided by the sum of the frequency. Okay, with an example we'll understand little more. Okay, so here is the example: find the mean weight of 40 boys. So we have to find the mean from the following data. Weight is given in kg and number of boys, that is the frequency. Okay, 27 kg. How many boys are there? 6 boys are of 27 kg. 12 boys are having 28 kg as their weight. 10 boys are having weight as 29 kg. Similarly, 8 as 30 kg and 4 as 31 kg. So we have to find the mean weight. Okay, so this information is given in tabulated form. Okay, so we have to use that formula that we have discussed just now, that is summation fi xi. So this one is the x, this variable weight is the x, and frequency is f. So we'll find the product of these two, these two, these two, these two, and these two, and that product will find the total. Okay, and it will be divided by the sum of the frequency, that means the sum of these all. Okay, let us do it here. So weight, that is the variable, is 27. Okay, so x will write here, the quantity which is variable, we have to know that, we have to identify that one. So this is the x, variable is this, because this is changing person to person. So this is x. So here we'll write 27 from this given data: 27, 28, 29 kg, 30 kg, 31 kg. Now the frequency, how many boys are there of 27 kg? 6. We'll write here. It's very easy. Now here 12, here 10, okay, 29, 10. You just see it is for the same weight or not, okay. So 10, 30 is 8 boys are there, 31 is 4 boys are there. Now here we'll fill this by multiplying these two. So here how much we'll get? 6 into 27, 6 into 27, these two you will find the product, okay. 6 into 27 we are going to get 162. Similarly 28 into 12, 336, 29 into 10, 290, 30 into 8, 240, 31 into 4, 124. Now the sum of frequency, that is summation fi, we have to find. So when we add these all, we'll get 40 here, and summation fi xi that we get here, we'll add this all, we'll get here as 1152. Okay, so now the mean we can calculate by the formula mean. Therefore mean is equals to summation fi xi by summation fi. The value of this is here, the value of this is here. Just to divide here, 1152 divided by 40. So we'll get the mean as 28.8 kg. Okay, so this is the mean. So this is the way to calculate the mean of this given data. Okay, first we have to form a table. We have to arrange the things from this to this in this manner. Then you find the sum of this frequency and find the sum of this fi xi, and then apply this formula. Okay, so this much for today. Thank you very much.